Hey everybody, Mr. Swirsky here. Let's go ahead and get our lesson started. We're going to start with points, lines, and planes, which are the basic foundation for geometry. Now we're going to begin with a couple definitions and then a couple examples. And then when we come back tomorrow, we'll work on some of those here in class. We'll have a couple of extra things and let you work on some others. So let's start out with a couple definitions here with points, lines, and planes. So we have the terms points, lines, and planes. Now we call these undefined terms, and we'll get into that when we come back tomorrow. But so we can't necessarily define them, but we can name them. So when we have a point, we name it with a single capital letter. So any capital letter represents a point or a vertex, anything like that. So that would mean that when we have our examples on there, we could use point A, or simply if you see a dot with an A, that's also an example of a point. A line. Line is always defined by 2 points. 2 points always make a line, and they're normally, if you're doing it through points, that means it's 2 capital letters. Or if you define the line with a single letter, it's going to be a lowercase, usually italicized, and that's the representation here. So you can call this line PQ, QP, or also line M. So it's usually going to be at one of the ends of the line to represent what it is. And finally, a plane. If a point is named with 1, a line is named with 2, a plane, let's see if we can guess it, is named with 3 capital letters. Or you'll also see usually a cursive capital letter in the corner, which is also a way to do that. So if we look at this example, we can name this BDC, which we call it plain BDC, or you can name it any way that you want to, DCB, CBD, all those crazy stuff, all those crazy things. Or if we see that italicized letter right there, we can also name it that way. So we could also call that plain K. So there's points, lines, and planes, how we can name them. Other point things that we have to pay attention to are what's called collinear or coplanar. Collinear are points that lie in the same plane. So if I give you, let's make this example. Here's a line. Any 2 points, 1, 2, so let's say A and B, these are collinear. They're on the same line. Now I could add them, and whatever I add, as long as it's on the line, those are also collinear. So all of these points are still collinear. Now the second I take it off the line, let's call this F. Point F is non-collinear because it's not on that line with the ones that are on there. Okay, makes sense. And so if collinear is points on the same line, coplanar is points or lines that lie on the same plane. So if I define that, let's make a plane. Let's call this plane. Let's use K. So any of these, if I make any points, A, B, C, D, whatever, these are all coplanar. Okay. Now, same thing if I also have these lines. So let's say this is line lowercase. Let's say A. This is line C. Those are both coplanar. Now, the second I put this off of the plane that I've defined, this is non-coplanar, which should make sense. So those are our 2 big pieces with collinear, coplanar, non-collinear, non-coplanar. Excuse me. Last few things for defining stuff. A segment. We define a segment as basically, think of like snipping off a line, and it's a piece of that. So where it ends on both sides, those are called endpoints. Still named by 2 capital letters, just the same thing with if I name a line. Now when we do the example of this, we have to define it. So I can call this PQ or QP. Now if I'm going to define it as a segment, I have to put stuff over here. Now you see I don't put arrows on it like I did when I was defining the line on here, where you see the lines with the arrows on there. We're defining that as a line because it has arrows. This one does not, and so we have to define it as a segment. So we have to be very careful how we name these, and so we're defining them correctly. I better give the definition here too, which should make sense. Line that ends on both. Oh, I already did that. Array is one end is a segment has an endpoint, and then it goes on forever. So it's kind of a one-sided line. Okay, it's still named the same way with a line, but in this case we have to show it as a ray, which means we have to give ourselves just one arrow. Or again, we could do Q, P. Sorry for the writing. I got to use my finger right now, so not working out too great. Last one, angle. Angle is simply just if we want to think of it in terms of segments, rays, and lines. It's the intersection of two rays at a common endpoint. So and then we call that endpoint the vertex. Okay. We name angles with 3 points. And the big piece on this is that the vertex is in the middle. Okay. Or we can also name this in one capital letter, which the letter would be the vertex. So what I mean by that is when I look at this, let's see if I can do this with my fingers. That's how we define an angle. We use the angle sign. And I can say A, B, C. And if you can look, B is in the middle because that's the vertex. Or I could also name this angle CBA, where again, B is the vertex. Okay, or because I just want to name the vertex, which is B, I can also call this simply just angle B. All those work out. Okay, oops. Last one, intersection's not that bad of a definition, but it makes a little more sense when we're talking about lines and planes. So when we're talking about lines intersect at a point, planes intersect at a line. So here, okay, they intersect along that whole thing. So lines that intersect at a single point, and then planes that intersect at a whole line. So we'd have to name that accordingly. Okay. So let's give you a shot at some of these. Well, let's do this one first one together here. So use the figure to name a line containing point K. Here's point K. So if I was going to name a line, remember it's any 2 points, name a line. So that means I can name this JK, and remember if it's a line, I have to symbolize it correctly. Or I can name it KL or LK, also works here. I could also call this JL, just has to be 2 points on the line, it doesn't matter what two. Or I could also call this by its italicized here, so I could call, I'm not going to write it down, I could also call that line A. Well, that would work also. So why don't you do this first one, we're going to get our Ed puzzle going here. So tell me, name a plane containing point L. So when we get point L, a plane containing point L, if I'm going to name it, remember I need to name it with 3 points, so or I can also use my italicized thing here, so I could call this plane B, or any 3 points. Now the big thing is that they're non-collinear, which means that they just can't all three be on the same line. So anything with M, so M, L, K, or I could use K, J, K, M. The only thing I couldn't do, which would be bad, would be J, K, L, and that's because they're collinear, and that won't work. Okay. So let's try this. Why don't you give this one a shot? Use the figure to name a line containing point X. Okay, that means that I can use any point along there, or I could also use this letter here. So XQ, QY, YQ, XY, line C, any combo of the points or using that letter C would work as well. Next one, now we're going to draw and label. So we're going to give you a chance to kind of look at this, and then we'll see if you can figure one out for yourselves. So it says I want plane R contains line A, B, and DE, intersects at point P, add point C so it's not collinear and non-collinear with A, B, and DE. So let's draw our plane here to start with. So that's plane R, right? So we've got this part done. Plane R, did that, okay? Next one, we need to contain line A, B, and DE, and it intersects at point P. So that means I need an intersection. These are lines, so I have to name that correctly. And then we have A, B, D, E. Oh, sorry about that. I got to get D and E. And then they intersect at point P. Now, if I want to add the non-collinear, that means it just can't be on these lines. So put it anywhere not on that line. Here, there's one. Point C works right there. It could go on any other part as long as it's not on the lines. So why don't you give it a shot? read this, figure out if it's A, B, C, or D, and then we'll come on back. So if I look at this, the big part is that plane D contains A, M, and T. Well, first, if I look at just that, C does not work because it contains T and M, but A is not contained in the whole plane. It's only contained right at Z, so that one's not going to work. I also need point F, well, intersecting at point B. So this one won't work because F is not, Z is supposed to be the intersection point and F is on this one. So we're left with the A or B. It says that F on plane D is not collinear. Well, on A, F is collinear. So the one that will work, B is the only one that's going to have that happen because it fits all the criteria. Okay. Last little few here. We got one or two left. Why don't you give this a shot again on number 1? So name 3 points that are collinear. There's only 3 that kind of fit in, and that's right there. So whatever combination, A, B, D, D, B, A, however you want to say that, those 3 points work. The next one we're going to talk about together, could points A, B, C, and D be coplanar? Now here's the tough part for a lot of people is because they don't see A, B, C, and D as on a plane, but that's only because all of them so far have been kind of highlighted with that blue. Now if I do that, here, let's call that yellow. I'm going to add a green. Think of like a knife edge going through a piece of paper. The tip is going through there and the rest of the knife is kind of on the bottom. This is A, B, C, and D are still another plane. As long as they have 3 non-collinear points, they make a plane. So that is a separate one. So plane S is a plane, and then A, you can say ABC, ACD. That's also a plane. So that's actually a yes. And the last one here, why don't you give this a shot? Where does AD intersect plane S? It intersects, so remember a line will intersect at a point. So right here. So point B is where it intersects. And the last piece, why don't we go ahead and give this a shot? Name the plane or planes in the figure. So let's get what I would consider the easier one out of the way. The one down here, we should be able to see that. So we call that plane T. Or I guess that's really the only way. There's no other non-collinear points that are on there. The other one is going vertically. So however you want to name that, we'll give you that option too. So we actually have 2 planes on the figure. Okay. That's all for now, guys. Take it easy. We'll see you on the next video.